Hey guys, I hope you're doing well. Today in this tutorial, we'll learn how to determine RNA's configurations. So we take a compound here. Before you start anything, let me just draw a small section of a periodic table containing the most common compounds that we need in organic chemistry. And by showing the arrow, we mean the more right we go on the periodic table, the atomic number increases, and same thing happens when you move down as well. Now to make everything clear, I will just draw the atoms that this compound has. Now that I have shown the atoms, we need to find the stereocenter for determining the configuration of this compound. We know the chiral carbon that has 4 different groups attached to it is our stereocenter. So we got our stereocenter here, and now we have to rank our 4 groups around the stereocenter based on their atomic number. Here, looking at the periodic table on top right, you can say the oxygen will get the number 1 priority, and we can also clearly say hydrogen, having the lowest atomic number, will get the 4, and number 4 group is on the dash here. It means it's pointing away from the viewer, or it's going away from us. If you see here, the other 2 groups connected with the chiral center, both of them start with carbon atoms. And how do you rank them? Because both have carbon atoms. Let's just make a comparison then. So we take the black circle carbon as the black carbon, and the other one is the green carbon. Let's say the black carbon atom is connected to a carbon atom to its left and 2 other hydrogen atoms, whereas the green carbon atom is connected to 3 hydrogen atoms, and carbon atom has the higher atomic number than hydrogen, so black carbon wins, and we assign number 2 to the black carbon and 3 to the green one. Now we trace the path 1, 2, 3, 4 around the compound. The group number 4 is on the dash and going away from us. On another note, remember, we'll always try to make sure that our number 4 is on the dash. So let's come back to the compound. We trace the number, and the path we trace is anticlockwise, so we call it S configuration. If the traced path was clockwise, we would call it R configuration. Look at this one. Now we know that we have to find a stereocenter. So we mark our stereocenter, which has 4 different groups connected to it. And if anyone thinks this one is the stereocenter just because of the wedge and the dash, you're wrong, because 2 chlorine atoms are attached to 1 carbon here. We have our stereocenter, and we'll rank our groups around the chiral carbon according to their atomic number. So oxygen gets 1, and let me draw the hydrogen for you because that is not shown here. So our hydrogen will get 4 because of the 2 groups attached to the chiral carbon have carbon atoms, and of course carbon has the higher atomic number than hydrogen atom. Now what about the black and the green circle carbons? Which one will get the priority here? Let's do the comparison again. The black carbon has 3 other carbon atoms attached to it, and the green one has 2 chlorine atoms attached to it, first of all, and also a carbon atom. So chlorine atom has the higher atomic number than carbon atom, so we rank the green one as 2 and the black one as 3. But like I said before, we always want our number 4 group on the dash or going away from us. So we switch the number 4 with the group on the dash, which is 1 here in this case. Now we have to trace the path around the groups from 1 to 4, and it shows clockwise direction, that is R configuration. But as we switch the group, when we will want our final answer or the final configuration, we have to switch the direction as well. Like if we have S, then the answer will be R, or if we have R, then the answer will be S. So here our final answer will be S configuration. Look at this compound. We find our stereocenter that is connected to 4 different groups. Now I draw it again, showing all 3 atoms connected to the chiral carbon, and try to set the priority. So oxygen wins in terms of having higher atomic number than other atoms. We numbered 1. and the carbon with the 3 carbon atoms is 2. But which one is going to be our number 3 and which one is going to be our number 4? Because both carbons have the similar atoms attached to it. In this kind of situation, we have to move out one further on the chain. We draw it again, and the arrows are showing the atoms connected to those carbon atoms. Remember to count the double bond as 2 carbon atoms. So the double bonded carbon atom wins based on the carbon having higher atomic number. So we rank the groups from 1 to 4. Let me draw it again. Now we already know if our number 4 group is not on the dash, we have to switch it with the group that's on the dash. We do it and trace the path around the compound from 1 to 4. The configuration seems S, but remember we have to switch it because we switched between 1 and 4. So our final configuration will be in the opposite direction, that is R. To summarize, we always rank the group according to the higher atomic number. The least prioritized group, or 4, will always be on the dash. Now if we have to switch between the number 4 and the group on the dash to make sure 4 is on the dash, your final configuration will be the opposite direction one. That is, like if you have R, then the answer will be S, or if you have S, your answer will be R. So see you guys next time and subscribe to the channel.